Well, good morning, everybody. My name is Mike Lee. I'm the lead applications engineer here at Forming Technologies. Today, we're going to be going through a web information session on material cost estimation and process planning of progressive parts. During our web information session, we'll be demonstrating the following. We'll be looking at determining the blank size for a progressive part. We'll be selecting or determining how we select the layout and type of carrier. We'll be looking at creating the process plan for a progressive part, an overview of the die costing and die size calculations, selecting a press from the press requirements generated by our process plan, and finally looking at the documentation and the report generation within our solution. Along with this agenda, so what we're going to demonstrate, what's in our software currently, we're also going to do a quick preview of what's coming in the next version of our software, which is due out roughly in June, in the June timeframe. So as you can see, we're going to start with FormingSuite. We're going to choose a new forming analysis. And at this point, we're going to import a step file. We do have the ability to import IGES or VDA as well with the out-of-the-box software, and we can add on translators like CATIA V5 and UG and things like that. So we're going to import our CAD file. In this case, we have a solid model. So as the software is importing the part, our topology engine is going to separate the surfaces into three geometry sets. One representing the top side of the part, one the bottom, and then the third being the mid, or the thickness surfaces. So in determining the blank size for a progressive part, we're going to go through some standard steps within our solution to quickly get that blank size for you. The first step is, of course, we're going to define our material type and thickness. So as it is a solid model, we're going to automatically enter that thickness for you, and then we can choose the material type from our material database, which is fully customizable and contains roughly 200 or so different materials by default. We also have the ability to add some cost information to all of our materials, either on a project level or on an application level. And this allows us to calculate the material costs through nesting and also include that when we're looking at our die cost as well. Once we've defined our material type and thickness, we do have some optional parameters that we can enter. So things like filling in the holes or filling in any notches. In this case, we're going to fill in all the holes, including these extrusion holes. So we're going to pre-pierce these prior to forming those extrusions. So we need to fill in those holes so we can set up our process plan. Once we've done that, we can then move into the next area of the software where we're going to convert essentially our surface model into a finite element mesh, as you can see there. And then we're going to define our punch direction or our forming orientation. Typically, we use the normal option, but we do have the ability, if we had a die line, to choose line. Auto will average all of the normals of every surface to give you an approximate direction if you're unsure. But as I said, the normal is the most common way. We choose a surface, and we're going to create the forming direction or tip normal to that surface. Next, we define our forming process, form or draw, and then we can solve for our blank. So you can see how quickly we determine the blank size, and in this case for a progressive part. We can look at things like thinning, for example. So we can look at the thinning plot, and then we can continue on. So we'll create the blank. So now we're at the point now where we have determined our blank size for a progressive part. So in this case, we're looking at about 340 millimeters by 296 millimeters. So the next thing to do is we are doing a progressive part, so we're going to go into our progressive nesting area. And the first thing we need to do is pick what we call the die plane. So the die plane represents where we plan to connect the part with our carrier. So you can move the plane with the slider, as you see here, and you'll notice the outer boundary of the blank is actually changing color and sort of toggling between blue, green, and red. What we're doing here is we're actually looking at the amount of edge movement that we're seeing from node to node, from the part to the blank. And based on that amount of edge movement, we're sort of recommending to you that either you would be able to do a solid carrier, maybe you need to do a stretch web, or where you have a lot of edge movement, it's going to be a very difficult area to carry. So based on that, we can then sort of in our mind understand or figure out what we plan to do with this part. So in this case, maybe we would be looking at something where we would be connecting in these areas here with a stretch web, so possibly one out with a double side carrier. So what we need to do is we need to tell the software some parameters, which we call the layout parameters. So our distance between blanks, our blank to coil edge distance, the thickness of our carriers, and the distance that we're going to enter for our carrier to part. So I'll just put in some values here. And then what we're going to do is we're going to look at how we're going to orient the part on the strip. So the way we do that is we use our rotation or constraint angle, and we're going to look at the first blank. We can show the part. So as we said, we want to connect in this area. So we'll probably rotate it something like that, 90 degrees. And then we can say OK. And then we can go to the summation icon where we then can choose all of our different types of layouts. So in this case, as we said, we were looking at a one-up double side carrier. So this is how we select the type of layout, and in this case, the type of carrier. So we'll say solve, and now we have a one-up double side layout. The next thing to do, of course, is to create our connections or our stretch webs. So we'll move following the wizard into what we call our stretch web workbench. And in this workbench now we can add in some webs. So we could look at, for example, maybe an oval web. And we have various parameters to define our oval web. So you can see them explained here. The width, the oval width, the trim clearance, the web width, all of these parameters we can manipulate. So we'll just maybe make the width 10, for example. We can preview it. And then it's a simple drag and drop. So in this case, you may have to zoom in sometimes to get exactly where you want it. So you can kind of center it in this area, for example, and we'll say OK. We can then repeat the process for the other side. So we'll switch this back to 10 as well, and we'll bring it down in this area. So we can try to line them up visually by sort of overlaying it. So you see the dashed lines, and this kind of drag it down. So if I bring it up and down, that should be roughly in line with each other. So say like that. I'll just zoom in to make sure. Yeah, it looks pretty good. And we'll say OK. The next thing we may want to add are the pilot holes. So we can choose the pilot hole constraint. And in this case, let's go with 8 millimeters because our carrier width is, I believe, 15. So it just gives us a little bit of space. And we can drop those in right where our webs are. And we'll do the same thing on the other side. So what we've done at this point now is we've created our layout. We've created our blank, we've selected our layout and our type of carrier. So the next step is to make sure that our carrier is actually feasible. So we have our simulation or web simulation icon. We select that icon, and what it'll do is it'll run a solver, and we're looking at, again, the amount of edge movement. So we have the blank, we have the final part. We can calculate the amount of edge movement. You can see it's a 3D display. And you can actually see in this case how the web has kind of slid a little bit from left to right. Excuse me. If there was any movement up and down, you would also see the carrier deform up and down. So it is a 3D display for you. Once we see this display, the next thing to do is to look at the actual feasibility of the web. And then this is where now we overlay our standard colors. So green for safe, yellow for marginal, and then red for split. So once we've determined our blank as well as our layout, establish that our webs are fairly safe in this case, we can then go into looking at creating the process plan for our part. So where we're going to go next is into what we call our prog.die process, and we're going to start defining some parameters. So the way that we define a process plan is we first break our part up into what we call part features or stamping features. You can see on the color bar on the right hand side the colors that we use to define various features. So a flange might be dark blue, an extrusion might be light blue, for example. When the part first comes in, it is considered all a first form. So it's considered that we would be forming the entire part as one feature. We can either generate all of the part features, so have the software try to find using various algorithms to calculate where those features are, or we can manually define them. So if we hit generate part features, we can then see in this case that it's done a pretty good job. We can see here the darts. So we have 4 darts. Here we have our 2 extrusions, an embossment, 2 unique flanges, but maybe we want to add this as a flange as well. So we would bend this up after we form that flange down. So we can follow the wizard again and say edit part features, and we could just hit the drop down menu, add a flange, and then just pick our 3 surfaces that represent that flange. We'll say OK, and now we've generated all of our part features. Once we've generated all of our part features, now we can start creating our process plan. So we go into what we call our process settings. In these settings, we're defining things like what is the feed direction from left to right, or is it right to left? We're also defining what we call the first hit line. So the first hit line we use to help establish where we locate the different stations, as well as how we segment what we call the scrap to generate our 2D process plan, which is for how we plan to gut the blank. We also define settings like what is our maximum length that we can have for scrap? What is the minimum length we can have for scrap? What is the threshold angle for cams? What is the minimum box dimensions for cams? Maximum box directions for cams. The tool depth refers to what is the amount of movement that we have or travel for a cam. Also, what is our maximum length for a cutout? And then what we would deem as interference. So if certain features are being formed in the same operation, if they are within a certain value, in this case 2 millimeters, we would then consider that to possibly be interference. So you can edit any of these parameters, of course, and we'll just say OK. Then the next step is to actually generate the 2D process, or we can do it manually as well. So we'll generate the process, and we can look at what the solution has given us. So in this case, we can kind of see it's kind of segmented a bit of these gutting stations. So maybe we want to have maybe 3 gutting stations. So one on the outside, one to take out the middle, and then the opposite side. So we can edit these things very quickly by either merging our scraps, or if we needed to, if they were too big, we could cut our scraps as well. So we'll choose the merge scraps icon in this case, and we'll use the pin or the push pin to keep the dialog open. Then you pick the scraps and hold control. So this could be, for example, 1 gutting station, and we'll say OK. Then we'll do the same thing on the bottom. So we'll pick those 3 segments and we'll merge them into 1. And then finally, in the middle, we see there's 2. So we can join those together, and I'm going to deactivate the icon because this is my last edit. And I'll say OK. So now what I'm left with basically is a plan that's saying I was going to use 5 operations by the software, but because I merged the scraps, now they need to be reassigned. So what do I plan to do in the first operation? Well, I'm piercing my pilot holes. At the same time, I probably might want to pierce the stretch holes in the oval webs, so I can drag those over, just simply like this. For the second station, I'm going to be piloting, but I'm also going to be removing the outside scraps. In the third station, piloting again, and maybe removing the center scrap. So these 2 stations are not required anymore, so I can just remove these operations. So I'm left with 3. Now, we may also want to remove the holes for our extrusions in our 2D process. So we can do that as well. You just have to find the holes. In this case, I believe, yeah, they're 1 and 2. So we can just come over here and we can specify that we're going to cut those out in our second forming operation or our second 2D operation, for example. Then we validate our process. So this is the first half of our process. It's giving me a warning saying that I'm processing a filled hole in 2D, and that's fine. So I'll say yes, and then I'll just save the process, and then I can close the table. So now what I have is the first component of my progressive process plan, which is what we call the 2D process. So this is essentially how do I plan to gut the blank so that I can start to form it. Next, we can go into our 3D process. So this is now where we're going to start assigning all of our part features. So the way we do that is we can either go on the Workbench Wizard toolbar, choose 3D process, and then choose define or generate, or we can just use the wizard and say generate 3D process. So in this case, it generated a process of 5 operations. Maybe I want more, maybe I want less. It's fine because I can easily edit my process. So typically what I like to do is, put in a few idle stations, so maybe one between the 2D process and the 3D process. Then we're going to do some forming, maybe another idle station, maybe one here as well. And then we want to look at what we have in terms of the sequence of operations. So in the first forming operation, it's calculated that we're going to do this first flange. This is probably not what we want to do. We probably want to flange everything down first and then flange up. So what we'll do is we'll move that flange from this operation to another operation. So for example, we could go from maybe here to here, for example. So in this first forming operation, we're going to form our extrusions, possibly maybe our darts, and maybe our exterior flange. So we'll find our darts and we can just drag them over. So we do something like this. And then maybe those other 2 flanges. So something like that. And then of course, maybe the first form as well. So what we're left with now is we're going to form those outside flanges, the first form. Maybe we'll save the embossment for the next operation. So maybe there. And then an idle station. And then we're looking at bending it up. Now we need to look at where we're going to form some of our pierced holes in the side. So we could bring this operation over so that this one comes here. And then we also want to look at maybe in this area here, we see the part has a bit of an angle. So rather than having a cam come in to pierce these holes, maybe we want to retip the part. So we can add in some tipping stations, for example. So that's not a problem. We can do that. Let me just rename this. So we can come in here, maybe add in a few stations. And maybe here what we're going to do is we're going to say that we're going to change the part orientation. So we want to rotate about the y-axis. So something like that. And then to get it to vertical or to parallel, we're looking at about, I think it's about 20 degrees. So let's put in 20. Yeah, that looks pretty good. So we'll say OK. So because we're doing a tip operation and then we want to keep that same orientation, what we need to do is we need to synchronize the part orientations. So we're going to tip it, pierce it, bend it back, and then cut off. So we only want to synchronize operation 100 and 110. So we'll say OK, and you can see now how that has been done. So we can continue looking at our process plan. So we're doing some piloting, so we can do that there. We also need to look at where we're piercing these holes. So those were the holes that we were looking at. So we're going to want to pierce those in 110. So we can move those over. So that's 13, 14, and 15. 120 is going to do the tip back, and then the 130 is going to do the cutoff. So if I scroll back, this is my cutoff. We'll do some piloting. So let's take a quick overview of what we're doing and make sure it's what we like. We can go into operation 50. We're forming the flanges and the extrusions, an idle station, embossment, the next flange, maybe an idle station. Then we're going to do some cam piercing of these holes here, as well as some other holes. So let's see what those other holes are. Scroll down the table. So we're doing those cam pierces there. And then we're also looking at maybe piercing these direct holes. So rather than piercing them in the form station, we'll bring them over and have a piercing station. So we have it like that. And then we're going to make sure everything is okay. So we have our cutoff. We can validate. It's maybe saying there's a little bit of interference, but I'm pretty satisfied that it's looking okay. And then we're going to save our process and close the table. Next, we can look at what we call our summary. So our summary now is going to put the two processes together, so your 2D process and your 3D process, and give you a summary of what's happening in the entire process. So we can look at it from the top view by default. We can also look at it through the side view, so we can see our retips or our different orientations. And then I can also, I'm going to drag the table up a bit, just so it's a little bit clearer for you. So you can see the software is going to calculate things like the progression, the width, the tonnage, so that's your load. It's going to give you a description of all your holes, whether they be direct or they be cammed, your scrap, your total cutting length, your front to back die size, your left to right die size, your minimum stroke, your minimum shut height, strokes per minute, and then finally your cost as well as your weight. We also have the ability to edit some of our costing parameters. So things like the labor rates, the die material. You can override calculated strokes per minute and enter strokes per minute. Number of operators, same thing, as well as your burden rate. Once we've done that, we can now look at essentially how we would select a press and the documentation and that by first we need to change our view so we get a nice view, and then we can go to the report. So the report is really where we can analyze a lot of our results. This is where we can look at what type of press maybe we would like to select. Otherwise, really, with our press selection, what we're doing is we run a very simple algorithm that you can customize your report where you enter in your own presses. So I entered in a few presses here. I have a 100-ton, a 250, a 600, and an 800. The report is a little choppy because I changed my resolution just for this web meeting, so it's a little bit clearer for everybody. But basically, the way it works is we look at all of the things that we calculated. So we're looking at our die size calculations, for example. The software is looking at the pitch, the width, the number of stations, and we're going to calculate for you the front to back size, the left to right size. That's one of the parameters that we enter when we're doing our presses. So when we start choosing our presses from the drop-down menu, what happens is any parameter that's exceeded by our calculated die will be highlighted in red. So for example, we can't run it in the 100-ton press. The 250 seems that it's good. We could also run it in maybe the 600. So that seems okay. We could also maybe run it in the 800. Oh, we cannot run it in the 800 because the strokes per minute is exceeded. So we use a very basic algorithm essentially to compare the presses in our database to the selection or the calculations that we've done in our process plan. This algorithm can be customized because essentially most companies are going to use different parameters for how they select the presses. Otherwise, what you would do is you could just do it yourself and you have all of these values. So your front to back, left to right, your stroke, your shut height, your tonnage, all of these things, you can use those to make an informed decision about which press to select. It also is creating simultaneously all of the documentation through this report. So in the report, you're going to have the side view, the top view of our strip. So that's our 2D and 3D process. You're going to have the information about your bounding box for your part. all of your nesting information, so what type of nest we use, what's our percentage, progression, width, part weight, all of these things, as well as our cost. Excuse me. We can also look at our die cost breakdown. So we're then going to look at where that cost is being assigned. So what percentages of that cost are going to construction? What percentages are going to machining, to material? We can also toggle between hours as well, because the software is going to calculate an estimate for the number of hours to manufacture the tool, and then where those hours have been allocated. So things like design, for example, would be about 10% of those hours, whereas 58% of those hours would be construction. Then when we go into setup details, again, it's going to give us an overview of our entire tool. So what's happening for our entire process in terms of number of holes, lengths of cuts, lengths of flanges, things like this. And then we're going to break it down into each operation as well. Then you have tabs for each operation where we're telling you, what hole is being pierced, what is the size of that hole, what is the area of that feature, is it direct or is it cam? So when you start toggling through, you can get all of our results. So I believe it was maybe 90 was a cam. Yeah. So in here you can find, here's the cam. What's the angle of that cam? What's the number of features that you're forming on the cam? What is the size of the cam, the height, the width, etc. So this report now obviously is going to be your documentation. It's going to help you with selecting the press, as well as giving you an overview of all of the calculations that we've done for our process plan, which we've taken from this layout here. The other thing I wanted to show you as part of our information session was an overview of what's coming in the next version. So this is a beta version that I have on my machine. It's not fully functional at this point, but there's a lot of things that we can touch on and show to get everyone on the same page in terms of where we're heading with the software. So our solution now, as you saw, this previous version here, we do have some limitations in terms of the types of layouts that we can solve. So with our 2D and 3D process combination for prog parts, the current version only allows you to do one-out layouts. In the beta version, or the new version that's coming, as I said, in June, mid-June, late June timeframe, we can now do 2 parts. So 2 parts means we can do 2 out, mirror, or 2 unique parts. So in this case, what I wanted to show you is the workflow that we use now for 2 unique parts. So what we would do is we would come into the geometry workbench just like we've always done, and we would import, instead of 1 part, we're going to import 2 parts. These 2 parts need to have the same material and the same thickness. So you can see here that they both have the same material type and the same thickness. If they're not the same, the software will not allow you to combine them into the same process. So you can see here I have essentially 2 different risers. We have this one here, and we have this one here. What we do is we go through the same process that we did, as you saw about 25 minutes ago, where I created the mesh, I defined the punch direction, I put on any pressure pads or any constraints if I needed to, and I unfold the part. Then what I do is I go back to the geometry workbench, I pick the second part, I assign the material, again, make sure it's the same, and then what I do is I manually open a process setup workbench, and I can continue through with a second process setup. So you can see process setup 2. Process setup 2 is going to have my second part where I'm going to mesh it. I'm going to assign a tip, a process, and any constraints. I'm going to unfold it to get a blank. Then what I do is I go into the blank definition workbench. So I create the blank from whichever forming. So in this case, the first one I did was forming 2. So it linked my blank to forming 2. Then what I do is actually, let me recreate this part just to show you. So I create a blank just like before, just like a single part, and it creates it linked to one of the forming workbenches. Then what I do is I go to the import icon, which is now called add second blank. In the past, it was only import blank. So what that meant was you had to import just a blank. Now it says add second blank. And what it does is it gives you the option to either import a second blank or link to a second blank. So link to a second blank means what is the other workbench that I want to link to? So in this case, I want to link to forming 1. So I'll say OK. And now I have one blank from forming 2 and one blank from forming 1. With those 2 blanks, I can continue on into my progressive nesting, where I have to define a die plane for both parts, where I can, just like you saw before, assign rotation angles, layout parameters, and then have my 2 blank nest. From my 2 blank nest, I can go into stretch web and I can create my connections. In this case, I chose to use solid carriers. From there, I can move into the prog die process, where I can assign part features, I can define process settings, I can do a 2D process now where I'm essentially gunning out the 2 different parts, and then defining a 3D process. And then we get to the summary, where we can then look at putting the 2 back together. So just like before, except now we're doing it with 2 unique parts. So now we have no limitations in terms of what types of layouts we're going to solve for when we're creating essentially a process plan for a progressive part. We can do 1 out layouts, 2 out layouts, as well as 2 different parts, as you can see here. The other things that are going to be added in the next version of the software, we're going to have a die material database. So if you go to your tools menu, you're going to see this die material database. And what this is going to do is going to allow you to define different types of steels with different costs, different densities, parameters, things like that, to help get a better or a more accurate cost. So in the current version, we're looking at costing parameters of die material, which is an average cost of all the different steels that you would be planning on putting in your tool. So the O1, the A2, the D2, 4140, et cetera. You would average those costs out to get an approximate die material cost. Whereas in the beta or future version, you're actually going to create a die material database, and the software will take those values out to give you a better or more accurate cost. So you're going to put in for cast iron as well as for steel. So things like 4140, A2, D2, etc. And finally, the other thing I wanted to show you was what we also have now within the software is we're going to have the regional settings. So you can see here in the summary table, we're talking about what region that this tool would be manufactured in and also who the supplier is. Excuse me. So in this case, I have a North American region supplier 2 using US dollars, and then we would calculate the cost that way. So you go into your die estimation parameters, and now you have your different regions. So you can choose between North America, different suppliers, and you would set those up similarly in the, under your project settings, under your regional die estimation settings. So in this case, I haven't set up any for a lot of the regions. I just had it for North America. I'm just showing you what's coming. So you can see here now we have all of those regional settings, and you can customize these. So you can put in all of your suppliers, for example, for North America, for Eastern Europe, East Asia, Pacific region, etc. Put in all of your suppliers, put in their labor rates that they use, put in their standards that they use for dies. So if I go back to North America, for example, we can look at, supplier 1 is using, casting shoes with this material versus supplier 2 maybe is using hot rolled steel. So we can look at customizing the database in terms of our regional areas as well as what types of steel we're using. So essentially that sort of covers the topics that we had outlined. We determined the blank size for a progressive part, as you saw in this example, very quickly to get our blank here. We looked at selecting the layout and the type of carrier. So in this case, progressive layout. Based on our edge condition, we chose 1-out double side carrier. Then we looked at the type of carrier in terms of webs. So we connected our webs. We looked at our simulation. In this case, everything was okay. So we went ahead with our process plan. So we generated a process plan for a progressive part. We did the overview of the die cost. So looking at the calculations, how we would select a press. So either using the press library and customizing that perhaps, or looking at things given in the results, so in the documentation, so things like the front to back size, the tonnage, things like that, and then of course all of the documentation and the report. So at this point, what I'm going to do is I'm going to unmute everybody and open it up to any questions.
Hey, Mike, I have
When is the version going to be available, do you think?
Pardon me? Sorry, what was the question?
When is the new version going to be available?
Yeah, so the new version,
of the software,
the new version is planned to be released mid to late June timeframe. I think more mid-June.
Mike, we're running the 2017.2. So when you at the very beginning you ran through opening up a new project and kind of zipping through defining material in punch direction, and it seemed like it went fairly easily, and your punch direction and your plane was fairly simple. What we're running is it almost seems as though you have to manipulate your XYZ axis when you're defining your punch direction in order to get a nice level where you want that die plane to be. Can you run through that again and maybe explain maybe what I'm doing wrong as far as picking auto or manual? Because it seems as though if you don't get a good die plane, then where you're looking for your stretch web or your solid carrier, you're constantly tinkering, trying see how you're going to make that work.
Right, absolutely. Okay. So what we're looking at here is sort of the die plane. So what you see here is it just happens to be that in this case, my tip axis and my global coordinate systems line up. So the way that the software works is when you bring in your part in whatever orientation, typically in car position, we use the global z-axis as your default for tip. Then what happens is when you define your local coordinate system or our tipping direction or punch direction, we create a new local coordinate system that uses z as your tip direction. So that's what that yellow arrow is. When we adjust the die plane, it is completely relative to the tip direction that we've defined, so our local coordinate system. So if you don't define this punch direction in an appropriate way, so say for example, let me delete a bunch of stuff so it will be faster. So if I define it something different, for example, so maybe something like this just for our purposes. When I go to the die plane, you see how the blank now is skewed on an angle? This angle now is relative to that new coordinate system that I've created. So the movement of the plane is relative to the punch direction. So you can see that there.
Right.
So really what you need to do is you really just need to make sure that you're using an appropriate punch direction. If you're using auto a lot, auto is a function really that I would use with caution, right? So like if you look at here, for example, if I choose auto, it's looking at this shape here, right? That's how it's saying I would want to form it. And the reason why it's doing it that way is because we created auto as an approximation if you're really not sure, right? So what it does is it looks at the part and it's just an average of all the normals of the part. So because we have this surface that's skewing up to the top, it's gonna, when you average it out, it kind of tips it in this way, right? So a good example that I usually use when I talk about training is if you had a part that was just a flange like that, right? you would obviously define the tip in this way typically, right? So you just do a straight flange. Whereas the auto function will create a vector here, a vector here, a vector here, and when it averages out, it does that, right? So that's what you're seeing here, right? Is it's doing that. So really what it is you just need to make
So
sure
you're
that you need to apply an appropriate tip direction.
so is it just that the example you used in car position when you brought it in, that major surface was pretty much flat in car position, or because again, some of what we're looking at, if you pick the manual or the auto, or what was the other option that you had there, the normal.
The normal, yeah.
Again, trying to play with those to get that arrow just right. It isn't necessarily easy, but that certainly. I'm looking for a shortcut rather than constantly playing with the gear shifters trying to get that to go.
This is probably something that's best if we maybe discuss offline. So maybe just fire an email to support@forming.com. I'll keep a lookout for it, and then maybe we can connect separately, and we can go through some of your specific examples.
Mike, I have a question about the new software coming out in June, as far as the die cost. If you have two different parts, so if you have a mirrored part,
yes,
I'm sure the calculation for the machine time is pretty easy. But if you have two different parts, is it going to account for the added design time and added machining?
I would assume it is. It should. If it doesn't, obviously it'd be something that we would need to adjust. As far as I understand, it does.
How do we confirm that? How would I mean, other than testing it out, I guess, but is there something that I can see?
Well, right now, as I said, the beta version, I can't even run the report right now, so I can't even see what it's coming up with yet. But that'll definitely be part of our testing and things like that, absolutely. So I also had a question in the chat box asking about the report here in hours. So you can see here in the die cost breakdown, it's hard to see because of my resolution, but you have the cost, and then you just have a toggle switch between hours. So what you see here is your total cost, and then your total cost is broken up into percentages for construction, machining, design, spot and tryout, and material. And then if you toggle between hours, then it gives you your total hours that it's estimated, as well as where the breakdown of those hours comes from. Hopefully that addresses your question. Does anybody else have any other questions?
Yes, I have two questions.
Sure.
One, can the software, you have the same thing, you just don't have the carrier with it?
Sorry, I missed the first part of the question.
Can the software be manipulated to represent a transfer die as opposed to progressive?
Yes. So this particular
We do both.
Yeah. So this particular information session was specifically geared for progressive parts. So that was sort of the headline of the webinar, right? Process planning for progressive parts. You can see here in my toolbar we have something called line die plan. I don't know. Let me move this here. Go to the workbench. I have something here called line die plan. So what happens is the way the software works is if I went through and I got to the nest, and then rather than doing a progressive nest, I went into what we call blank nesting, which allows you to do 1 up, 2 up, like your standard sort of blank dies, as well as your sheared or cutoff dies, rectangles, trapezoids. That will force you into the same sort of idea with the progressive parts, except it's geared for tandem and transfer parts. So there are additional settings that we need to define when we're doing those types of process plans.
Okay, and then the second question is related to the unfold. So Typically, the issue with forming simulation softwares for sheet metal is that your unfold will tell you your trouble spots.
Correct.
In terms of the thinning that can occur.
Yes.
Do you have forward incremental simulation that actually shows the stresses going through the die as the part's processed, as opposed to the one-step unfold?
Yes, we do. So the process planning software.
And if that's another session, that's fine. We'll get that information. I just want to know if the software is capable of it.
Yes, it is capable. So someone else is asking about if our layouts, and I'm not sure what layout you're referring to, can be brought into SolidWorks. So for example, this layout could be exported as an IGES or a DXF, which of course could be brought into SolidWorks. The geometry from the process plan, I don't believe we can export at this point. So all of those intermediate steps. Does anybody else have any questions?
You can offer additional webinars like this. This is really invaluable.
Yeah, I believe we'll be doing a lot more of these type of webinars going forward in the future. And as I said, we'll try to, because it's within an hour, we'll try typically to focus on just a specific solution, right? So like in this case, we're looking at process planning of progressive parts. Maybe in the future, and don't quote me on this, but maybe in the future we'll do process planning for transfer parts or tanda parts, for example. Maybe we'll do an incremental information session, things like that.
Question regarding the export. You said the process plan that you have, you can export the IGES or the DXF.
Not the process plan.
You're only going to
the nest layout. This layout that you see on the screen can be exported. We can't export the process plan at this point.
You can or cannot?
Cannot.
Cannot, okay.
No.
And the export is only going to be the surface only. It's not extruding it out to create an actual sheet thickness.
Correct.
Correct. It's just
correct.
Top plane, middle plane, or the bottom plane.
Correct. It'll be the plane that you started with. So like in this case, I started with the top side of the part versus the bottom side.
Right.
So it would bring out the coincident surfaces off of this top side. So then if you wanted it to be thickened in your CAD system, you could just thicken it in the appropriate direction.
Correct.
But you don't have anything.
Okay.
Yeah, so again, a question again about the hours. So again, yes, it does break down the hours. So you can see here the die construction hours breakdown. In the report, it's just simply a radio button between cost. So you can see the total cost here being about 170,000, and then versus the number of hours being about 2,000 hours. So that's once you've created the process plan and created the report, that information is available in the report. So a lot of the documentation information is all produced within the report for the process plan. Total die weight. So in this case, we go to the initial page of the cost report, and we can find, scroll over here. So here's your die size. Where did it go? Die weight. Setup details. There. Should be here. There's the weight there. So the weight is summarized in the setup details here for the entire process. You can see here the die weight being about 12,000 kilograms for this particular case. Are there any other questions? So it looks like there's one other question here about how the number of hours are generated versus wire or machining center. So really what the software does is there are algorithms in the background based on the size of the part, based on the sort of the standards that have been pre-programmed that are going to count for CNCing, for EDM, things like that. And again, you know, they can be customized, but you know, it really depends on, again, doing some benchmarks and things like that to see how close they are. Because if they're really close to what you're doing, there's no need to customize, but in some cases, perhaps it might be necessary. Is there any other questions? Okay, well, if there aren't any other questions, I just want to say thank you to everybody for taking the time to come and listen to our web information session about material cost estimation and process planning for progressive dies. Thank you all for your time. Bye now.